For this task, we need to calculate the area using polar coordinates, because we have a function defined in terms of polar coordinates. Rho is a function of the angle phi, and it is equal to 2 plus the cosine of 2 phi. So if we plot this function, we have to remember how phi is defined. Phi is defined with respect to the x-axis. It is an angle defined with respect to the x-axis. If phi is equal to 0, for example, the function is equal to 2 plus the cosine of 0, which is 1, so it's 3. So here we have 3. And for example, when phi is equal to pi over 4, we have the cosine of pi over 4 times 2. So cosine of pi over 2, which is 0. So it's just 2. Here the function is 2. Whereas if phi is equal to pi over 2, we have cosine of pi. So it's minus 1. So at phi equal to pi over 2, we get that the function is equal to 1. So it is something like this if you draw the function, and then it is periodic. So the function has some kind of this kind of shape, more or less. It's not really precise, but you should get the idea. It is something like this. And in order to calculate the area, we need to calculate a double integral. So we can calculate a double integral, for example, or just a simple integral. So in general, when I want to find an area of a function in 2 dimensions, I can either integrate a function f of x dx, or I can integrate a function f of x y dx dy, and this would be, in general, this would be a volume. But if f of xy is equal to 1, then the integral dx dy can also be an area. This would be an area in 2 dimensions. And if we use polar coordinates, this integral will become integral over rho d phi. Sometimes this angle is called theta, but doesn't matter. So the area will be a double integral. We have to integrate from the origin 0 to the curve, which is given by 2 plus cosine of 2 phi rho d phi, and phi is an angle which ranges from 0 to 2 pi, because we have to go from here all the way around this curve. So we need to move all along the plane, right? So this is the integral that we have to calculate. The integral over rho d rho is rho squared over 2. So we have integral from 0 to 2 pi, then we have rho squared over 2, so that's just 2 plus cosine of 2 phi squared over 2 d phi, and this is equal to integral from 0 to 2 pi. Let's put 1/2 here, and then we have 4 plus cosine squared 2 phi plus 4 cosine 2 phi d phi. And now this is a simple integral to carry out. We have integral of 4 d phi, which is just 4 phi, and then we have to evaluate it between 0 and 2 pi, so we get 1/2. This is just 4 times 2 pi, and then the integral of this is also quite easy. That's just plus 2 sine 2 phi, the integral of this, because the derivative of this is just 4 cosine 2 phi. And then we have the integral of this function, cosine squared of 2 phi, that I will do below. So here I'm going to leave some space, and we have to evaluate it between 0 and 2 pi, actually only this part. So let me put a square bracket, a curly bracket here, because I've already evaluated this first part. And then I have integral of cosine squared of 2 phi d phi, which is integral of 1 plus cosine of 4 phi divided by 2. I have used a simple trigonometric formula, and this is equal to phi over 2 plus sine of 4 phi over 8. So this is the formula, the formula for the integral there. And therefore in here I will replace phi over 2 plus sine of 4 phi over 8. And then after I evaluate it, so when I evaluate this, when I evaluate sine of 2 phi from 0 to 2 pi, I will get 0, and I will get 0 also for this part. So this will give me 1 over 2, 4 times 2 pi, plus 2 pi over 2, which is just pi. So in here I get 8 pi plus pi, which is 9 pi. So I have 9 halves pi. And this is the result of the integration.